So we're going to go through the explanations of the 14 questions on our practice quiz or test. I'm not sure what it's going to be yet. Practice assessment 8.1 to 8.3. Number one, we have this fraction that we need to simplify. And in order to simplify this fraction, you need to factor to get multiplication to be able to cancel things out. You cannot start canceling x's with x's. That'd be incorrect, right? So the first thing I would do is switch this x squared and the 4, but that x squared really is a negative x squared. So I want to put that negative x squared first and the positive 4 second. So I want to put the negative x squared in the front. I want to write it up here, negative x squared plus 4. Now the x squared is negative, and I'm used to having a positive x squared. So I want a positive x squared. So what I'm going to do to make that a positive x squared is I'm going to factor out a negative 1. Okay? When I factor out a negative 1, I will now have a positive x squared, but with a minus 4 on the inside. Okay? Now, on the inside, we have a x squared minus 4, which is a difference of 2 squares, right? So we could actually factor this difference of 2 squares. So you could think what times what is negative 4, that if you add together is the middle value, which there is no middle value. So that would obviously be a positive 2 and a negative 2. So I'm going to rewrite the numerator. First of all, here's my fraction. But rewriting the numerator, you have that negative 1. And then this x squared minus 4, I'm going to rewrite it in factored form with an x and with an x. And you think what times what is a negative 4, that if you add together is nothing. That would be a negative 2 and a positive 2. And unfortunately, that's the easy part. Because factoring the bottom one is more challenging, because notice that there's a number out here. So you can't just think what times what is 2, that if you add together is negative 7. It doesn't work that way. If you have a number out here, you got to do that multi-step process. Yeah, the A times C. So the first step is going to, I'm just going to put step 1, A times C. That's 3 times 2. That is 6. That's step 1. Step 2 is to think of the multiples of 6. It's pretty easy. 1 times 6 or 2 times 3. And you want to think which pair of numbers combines together to give you the middle value, which is negative 7. Well, if I add 2 and 3, that gives me a 5. That's not a 5. If I add 1 and 6, that'll give me a 7. That's a 7, but it's a negative 7. So I have the right numbers, just the wrong signs. So these are the correct pair of numbers, but I need to change both signs to a negative 1 and a negative 6. Now, step 3 is where it gets interesting. That's where you have to set up your factored form format that's going to be incorrect. You put the AX with your number right here from step 2 and number right there from step 2. In this case, what is AX? AX is going to be a 3 with an X, right? So whatever you have here, just even if it's Y's, just ignore the 2. If you had a 3y squared, it would just be a 3y. Ignore the 2. So you put 3y there and 3y right there. In this case, it's a 3x and a 3x. So let me do that. I have a 3x and a 3x. And now the numbers have to come from step 2, the negative 1 and the negative 6. They go right in there, negative 1 and negative 6. And then for the fourth magical step, that's where you just divide both terms in each binomial by whatever you can. We call it magic because you're not really factoring out something. You're not really you're just magically dividing. Like you can't divide this by anything. Right here you could divide this by 3. So if you did magically divide by 3, well, first of all, the first one didn't change. It's a 3x minus 1. But the second one, when you divide it by 3, it'll become a 1x minus 2. And ladies and gentlemen, this is the factored form of this quadratic trinomial. So I'm going to write that in the denominator. 3x minus 1, x minus 2. So this was challenging. Multi-step question, both on the numerator and on the denominator. Now we could cancel things out because we have everything in multiplication, with multiplication. So the x minus 2 up on top and the x minus 2 on the bottom completely disappear. And that's it. That kind of was lame. All right, whatever. So what do we have here? We have a fraction left over. We have the x plus 2 up on top. I'm going to keep it in parentheses because there's a negative sign, or a negative 1 in the front. And then there's the 3x minus 1 on the bottom, which I don't need parentheses because there's nothing else left over on the bottom. And if we look for those answers, first of all, we don't see any with parentheses. So they either distributed the negative sign, the negative 1 in, or they put the negative sign out in the front, right? Which it looks like they put negative signs out in the front. So if I did do that, erase the negative 1 and put that negative sign out in the front. I'm going to do it in red, or there you go, and put that negative sign out in the front. That means that we don't need the parentheses anymore. So it would be x plus 2 over 3x minus 1 with the negative in the front. X plus 2 over 3x minus 1 with the negative in the front. That should be our correct answer, and voila, it is. We got a green dot right there. All the other ones are red. That's the only one that's green. Okay, you guys get the idea. That's the correct answer. Let's move on. So some of you might be thinking, well, when we had the negative 1 out here, why not distribute? Yes, you could have done that. Another acceptable answer would have been negative x minus 2 over 3x minus 1, right? But most of the time, we leave it in factored form, so it's good to have the negative 1 out here in parentheses. Or you could put that negative out in the front. Either way, it's correct. But of course, on multiple choice tests, the problem with multiple choice tests is you got to be able to identify the correct answer based on what you have provided. So right here, the only option would be to move the negative out into the front. That would give you this answer right here. Number 2. We want to simplify. We want to cancel things out, but the only way to cancel things out is if it's in factored form. So whenever you have a negative x squared second as opposed to first, move it to the front. So take the negative x squared, move it to the front. So you're really going to have a negative x squared with a plus 36, okay? So you have a negative x squared plus 36. Now, in addition to that, you know what? I am going to make like a scratch paper right here, I guess. So I don't want a negative x squared. So I'm going to factor out a negative 1. And on the inside, I will now have a positive x squared with a minus 36. Are you with me? Yay? Okay. Now, in addition to that, I could continue factoring the inside because it's the difference of two squares. You have x squared minus 36. You could think what times what is negative 36? That if you add together is a middle value, which is nothing, right? 6 and negative 6. So let me go, whoops. You guys did not see those answers. Yes, you did. Oh, well. So up on top, I'm continuing to factor. I still have the negative 1 out here, but I am now going to factor the x squared minus 36 to become x plus 6, x minus 6. All right, so this upper left numerator on the first fraction got rewritten to this. Okay, so we first switched it, factored out a negative 1, and then finally completely factored all the way up here. Okay, so up here we really have this. Let's factor what's down here. Down here we have an x squared plus 5x minus 6. Because the a value is 1, we're happy because maybe we could factor with an x right there and an x right there. All we got to do is think what times what is negative 6, that if I combine together is positive 5. Anybody? What times what is negative 6 that if I add together is positive 5? Positive 6 and negative 1. That is correct. Positive 6 and negative 1. Okay, so I have factored the bottom. Let's continue factoring. You know what? It's getting messy. Let me rewrite this thing. So my first fraction has a negative 1, and then it has the x plus 6, x minus 6. And in the denominator, we have the x plus 6 and the x minus 1. Okay, and then we have this division that I am going to change to multiplication as long as I flip that second fraction. So that second fraction is going to be flipped. So as I move this 2x minus 2 up to the top, I might as well factor out what? A 2. Bless you. Okay, so we're going to pull out that 2. What's going to be left on the inside? An x minus 1. Okay, Again, I factored out a 2 from here as I moved it up, so that's what it is. I factored out the 2, I have x minus 1 left over. When I take this 3x minus 18 and move it down, I might as well factor out what? A 3 as I move it down. And what's going to be left on the inside? X minus 6, perfect. All right, so we have completely factored all numerators, all denominators. We flipped the second fraction. Now we could cancel things out, right? So what is alike on top and bottom? We have the x plus 6 with the x plus 6. We have the x minus 6
and x minus 1.
with the x minus 6. And we also have the x minus 1 with the x minus 1. Dang.
Now I have -2.
Negative 2/3 is the only answer, because when you multiply -1 times 2, that's -2 and over 3. So negative 2/3 is the answer. And obviously, if you look for that answer, it's not there. And that's why the answer is none of these. Next question. We want to subtract these fractions. In order to add or subtract fractions, what do you need?
LCD.
An LCD. So how do we find the LCD? First, like always, factor anything possible. So this first denominator, x squared plus x minus 6, you could factor it by thinking what times what is -6, that if you combine together is +1. And what would that be? +3 and -2. Isn't that right? 3 times -2 is -6. And if you add it together, it really does give you a +1. Okay? So we factored the first denominator. Let's factor the second denominator. What could I pull out? What could I pull out on the second denominator? 2.
2 and
All right. So we have the denominator of the first fraction that's in factored form. We have the denominator of the second fraction that's in factored form. To write our LCD, we are going to have to write down what's in common once and then bring down everything else as well. So let me do this. I am going to make this a whole lot bigger and use this as scratch paper. That's the wrong answer anyway. Okay, here we go. So my LCD will be the x minus 2. Bring down the x plus 3 and bring down the 2. So there's my LCD. 2, x minus 2, x plus 3. Okay, now I'm going to write my second fraction also with that same LCD, 2, x minus 2, x plus 3. Once again, I hope this makes sense. You take what repeats, the x minus 2, and you write it once. And then what about everything else? You bring it down. So the x plus 3 goes over there, the x plus the 2 goes over here. And that's your LCD. You write it twice, and then you go back and ask yourself, what do I do to this first denominator to get this new LCD? What do I do to this first denominator to get this new LCD? Multiply by 2. So you're going to have to multiply both top and bottom by 2 to get that new LCD. So when you multiply 2 up here times 1, that will give you a 2 up there. Okay. Now on the other one, let's take a step at a time. What's missing from here to get to this new LCD? The binomial x plus 3, right? So this time I'm going to show my work. I need to multiply both x plus 3, x plus 3. So yeah, distribute the 5. Now be careful, because this is not a regular 5, guys. It's actually a -5 because of the minus sign. So -5 times x, wait, maybe not. Let's not do that. That's if you're rushing through this, yeah. But right here, we're going to call it a regular 5. Why? Because I already wrote down the minus sign. If I would have distributed the -5, included it, then it would have been a plus sign. I don't want to confuse you though. So let's just distribute the 5. 5 times x, 5x. 5 times 3, 15. Now that we have the LCD, now we could actually combine the numerators. So the answer will be over the LCD 2, x minus 2, x plus 3. But I need to do 2, take away 15, and the minus 5x in the front. This is where you need to distribute that minus sign to both terms, making this a -5x and making that a -15. So when I combine the 2 with the -15, that'll give me a -13. and then the minus 5x will be out here in the front. So this should be my final answer. But then again, they could have maybe factored out a negative 1 and put it as a minus sign in the front. Who knows? So let's take a look at our answers over here.
It had negative 3x plus 5 as the answer. I'm pretty sure.
I made a mistake on this video right here, but I will have this as a final option out here. So forget about these answers, but I will put this guy as the final answer on the practice test. So on this question, we're going to subtract two fractions, and we need a common denominator. And the best way to do that would be to factor first, and then identify your LCD. How do you do your LCD? By taking what repeats, writing it down once, and then bringing down everything else. So on the first denominator, we're going to factor out a 3, and what would we have left? We would have left a 2x minus 3, okay? And on the second denominator, we could factor out a 2x, and what would we have left? We will also have a 2x minus 3. So all I did was factored this to become this and factored this to become this. So for my LCD, see, my problem is a subtraction problem of two fractions. I have one fraction, take away another fraction. But down here, I want my LCD. Right? I want my LCD in the denominators. Okay? That way I could actually subtract them. So how do I get my LCD? Well, I take whatever repeats and I write it down one time. So the 2x minus 3 that repeats, I write it down one time. And what about everything else? I bring down everything else. So I have a 3 and a 2x. So I'm going to bring that down, 3 and 2x. It'd be a good idea to put a multiplication dot between it. That way you don't think it's 32x, right? 3 times 2x. So technically at the end of it all, this is going to become a 6x, right? But I'm just going to leave it like that for now. So that's my LCD. I'm going to rewrite it on the other fraction. And then I ask myself, what do I do to this first denominator to get this new LCD? What's missing? Anybody? The 2x is missing, right? The 3 is right there, the 2x minus 3 right there, but the 2x is missing. So I need to multiply both top and bottom by that missing 2x. So I'm going to multiply by 2x, multiply by 2x, and that'll give us a 2x up on top. Now on the other fraction, what's missing? We have this, but we need this. We're missing a 3, so multiply both top and bottom by 3 times 3 times 3. That'll give us a 9x, okay? So now that we have an LCD, we could actually do 2x take away 9x and write that over the denominator, the LCD of 6x times 2x minus 3. So my answer, bless you, my answer will be over 6x times 2x minus 3, okay? And what is 2x take away 9x? Negative 7x, right? Now, you might be thinking, there's my answer, but you could actually cancel out this x because there's multiplication. It says negative 7 times x, and down here it says 6 times x. So the x up on top with the x on the bottom really do cancel out. So your final answer is negative 7 over 6 parenthesis 2x minus 3. That is your answer. Now the negative might be written on top with the 7, or it could also be written just out here in front of the fraction. But that's your final answer. Let's go to the multiple choice options to see where it's at. And it looks like, let me just uncover these. This is the correct answer right there. The negative's out in the front, 7 up on top, 6 on the bottom, 2x minus 3. That's what we had on our work. So right here, again, we need to subtract these two fractions. In order to add or subtract fractions, you need an LCD, you need a common denominator. And again, to acquire that common denominator, it's a good idea to factor the first denominator, factor the second denominator, and then your LCD is whatever matches up, whatever repeats in both. You could write it down once, and everything else bring it down as well. So we do have a bunch of y's right here instead of x's. And what we have to ask ourselves is, what times what is negative 16 that if I combine together is negative 6? Now, if you're struggling, go ahead and make a list, right? How could I get negative 16? I could get negative 16 by doing negative 1 times 16, negative 2 times 8, negative 3 times, negative 4 times 4. So which pair of numbers combines together to give us negative 6? The negative 2 and 8 right here, that if you add it together, it'll give us a positive 6, and we want a negative 6. So we have the right numbers, we just have the wrong signs. So just change the signs, make that a negative 8, make that a positive 2. So you really do have a positive 2 and a negative 8, and that is factored. Now we could go and factor the other one. Again, the other one, same process. What times what is negative 8? That if you add together is negative 7. If you need to, make a list, but I'm pretty sure you could figure it out that it's positive 1 times negative 8, right? Positive 1 times negative 8 is negative 8. If you add it together, it will give you a negative 7. So both fractions have a factored denominator now. Now that I know that it's factored and factored, now I could simply write down my LCD really easily by taking what repeats and writing it down once and then bringing down everything else. So again, I have two fractions that I want to subtract. So I'm going to start by writing my two fractions that I want to subtract. Okay, and down here I'm going to write the LCD. What repeats? The y minus 8. So I'm going to bring that down and write it once. And what else is left over? Well, there's a y plus 1 and there's a y plus 2. So I'm going to write the y plus 1 and the y plus 2 down here as well. That's what comes down. So this is my common denominator, my lowest common denominator. And of course, you're going to have to write it over here as well. And then you go through the process thinking, what do I do to this factored form denominator to get this new LCD? What's missing from here? The y plus 1, right? So I'm going to multiply both top and bottom by y plus 1. When you do that, y plus 1 on the bottom, y plus 1 on top. Remember, you're going to have to distribute the 3. 3 times y is 3y. 3 times 1 is 3. So 3y plus 3 is the numerator of the first fraction. The second one, what's missing on this denominator to get to the LCD? The y plus 2, that's right. So let's multiply both top and bottom by y plus 2. Y plus 2 over here, y plus 2 over here. So 2 times y is 2y. 2 times 2 is 4. And now that we have the LCD, the common denominator on both fractions, now we could actually worry about this numerator, take away this numerator. And of course, you're going to write your answer over the LCD, y plus 1, y plus 2, and y minus 8. Okay, so what we need to understand is that this minus sign belongs to the binomial 2y plus 4. That means you need to distribute. Okay, so when you're combining y's, you have 3y take away 2y. What's 3y take away 2y? 1y. Okay, you don't even have to put the 1 if you don't want to. You could just put y. And then you have the positive 3 that when you distribute that becomes a negative 4. What's 3 take away 4? It's negative 1. Okay, so negative 1. So this is our answer. That is our answer. But I believe on quizzes, the way I ask this question, the instructions, I believe, say, after getting the LCD and doing the math, type in only the numerator of your final answer. So what's the numerator of our final answer? Y minus 1. So if you type that in, y minus 1, you're going to get full credit. Okay? So that's how to do this question. Let's move on. En esta pregunta, why am I talking in Spanish? On this question, we're gonna treat this problem like if it were two separate problems, right? We're gonna first do the subtraction of these two fractions, and then we're gonna worry about dividing by this fraction right here. Okay, so I am going to cover up that bottom part and just focus in on the top part. In order for us to subtract these two fractions, we need an LCD. In this case, it would simply be writing them both together, right? Nothing repeats. It's just an x times x minus 7. So the common denominator of the first fraction and the second fraction will be the x times x minus 7. X times x minus 7. Okay. Now the question is, what do I do to this first denominator to get this new LCD? Well, I multiply both top and bottom by x minus 7. So when you multiply by x minus 7, both on top and bottom, you got to recognize that that x plus 5 is a binomial, so you actually need to distribute and go x times x, x squared. X times 5 is 5x. Negative 7 times x is negative 7x, and negative 7 times 5 is negative 35. And when you combine the middle terms, the positive 5x and the negative 7x, you get the negative 2x. So what we really have here is x squared minus 2x minus 35. That is the numerator of our first fraction after getting a common denominator. Now for the second fraction, it's a lot easier. If I want to change this x minus 7 to become an x minus 7 times x, obviously it's missing the x. So times x there, times x up there, you're going to have a 32x up here. Now that we have a common denominator, now we are able to subtract the numerators. Okay, so my answer will be over the LCD x times x minus 7. Okay, question is, this negative sign belongs to the 32x. So what we really have here is x squared. Can't combine it with anything, bring it down. Negative 2x, you could combine it with the negative 32x. What do we get? A negative 34x. And then at the very end, we have the negative 35. Okay. And from there, you might be thinking, well, that's our final answer. But I do have a quadratic trinomial up here. Maybe we could continue factoring that. So let's see. Could I factor that top one? Yeah. What times what is a c value, negative 35, that if I add together is negative 34? Positive 1 and a negative 35. Thank you very much. And on the bottom, we still have that LCD of x times x minus 7. So what we need to remember is that this right here is barely the top part of our original question. The top part, the numerator. Let's go back to the actual question itself. You see, we were working on this, but we still have this bottom part, the divided by the fraction 1, or x plus 1 over x minus 7. So I need to divide this by that, okay? So instead of writing it as a division bar that's vertical, I'm going to write it as a division sign with the x plus 1 over x minus 7 horizontally as opposed to underneath it. So I just wrote it right there, and now I could focus on this again. The first fraction is not going to change. This division will change to multiplication as long as I flip the second fraction, x minus 7, x plus 1. And now we could cancel things out, and that's great because I do have an x minus 7 up there that cancels with an x minus 7 down here, and I also have an x plus 1 down here that cancels with the x plus 1 up there, giving us our final answer, x minus 35 over x. Could I cancel the x's? No, because of the subtraction. So that is our final answer right there. Man, that was a long problem. I'm sorry. There's a multiple choice answer, x minus 35 over x.